About 80% of California's water consumption goes into agriculture. The state produces over 30% of the country's nuts, fruits, and vegetables. Many of these crops are sensitive to salt. Salinity in irrigation water can lead to degradation in soil quality, lower crop yields, or even permanent crop damage. There are two solutions to this problem: overwater the soil to flush out the salt, or remove the salt from the initial irrigation water. The overwatering approach, called leaching, is what farmers are using currently, and it is a major contributor to water overuse and polluted runoff.
With the eddy, farmers will have a tool to understand their salt problems and act on them. Instead of flushing thousands of gallons of an increasingly scarce resource, they're able to achieve greater crop yields with only the water that they need. Desalination used to be limited to a process called distillation. In recent years, scientific advances have opened up new, cheaper ways to desalinate, and one of those methods is called electrodialysis.
In electrodialysis, an electric field is used to separate salt ions from the water. In order to divide the salty water from the clean water, the desalinator is divided into channels, and ion exchange membranes are placed between each channel. As the water moves through the eddy with an electric field applied, the salt ions will migrate into every other channel, leaving a low salt water that is ready for irrigation. The resulting salty water is recirculated into the salty channels to pick up more salt until it becomes too salty to use. At this point, it is released into an evaporation pond or storage tank, and the salty channels are refreshed with new water.
Since we have a wide audience with varying skill levels and technology, our interface approach needed to be bold, intuitive, and flexible. Designing for the feel of a native app, we structured our web app navigation to match familiar mobile icons and made the most important information as graphic as possible. Our goal with our Eddy app is to empower farmers to make decisions for their crops as quickly as possible and to recognize patterns over time. To accomplish this, we built the dashboard and troubleshooting screens with clear, colorful indications of positive and negative states, and gave on-off controls as remote failsafes to minimize any risks that could damage crops. For better analysis, we provide summary graphs and exportable reports that save salinity states, flow, settings, and eventually power usage to help target efficient practices on a daily basis and over longer time frames. We hope to expand the user experience by providing more granular data settings and visualization tools in the future as we tool the Eddy itself to be more efficient, more cost-effective, and easier to maintain.